Good morning everyone, this is Shilpa from CSC department. Today we are going to discuss the overview of language processing. The outline of this today's session is what is meant by the compiler, assembler, interpreters and loaders, linkers. And finally we are going to discuss structure of a compiler. Let us start with one by one. Let us start with the steps of language processing systems. First, the source code is given to the preprocessor and preprocessor can generate the pre-processing code. Finally, that output goes to the compiler. Compiler can generate the target assembly level language code. This assembly level language code goes to the assembler, and this assembler can generate the relocatable machine level language code. Finally, that code goes to the linker. In this linker, we are going to link the library files, relocatable files as well as the modules. Finally, we are going to generate the executable code. That executable code goes to the loader. Using this loader, the final code can load into the memory. After that, we are going to generate the final machine level language code. Let us start with one by one. What is meant by the compiler? Using the compiler, one type of the language to convert into the another type of the language. Means one type of the language is also called it as a source code. That source code is also called it as a high level language code. That high level language code goes to the compiler. Compiler can translate that code into the object code. That object code is also called it as a machine understandable language code. Examples of the compiler is C, C++ languages. Next, we are going to discuss the assembler. The source code is an assembly level language code. This assembly language code goes to the assembler. Assembler can translate that assembly level language code into the object code or machine understandable language code. That goes to zeros and ones only. While writing the assembly language code, we are going to use the assemblers. Through the assemblers only, we are going to write the assembly level language code. That assembly level language code can be converted into the machine understandable language code using the assemblers. And finally, we are going to discuss the interpreters. Interpreter act as the same as a compiler, but here, the assemblers can translate the line by line code. Whenever any line can generate the error, let us stop the remaining program execution and generates the error. That is the speciality of the interpreter. The examples of interpreter is Perl, Python and MATLAB. Now let us discuss what is meant by the linker as well as the loaders. After generating the machine level language code, then link to the linkers. In the linker part, we are going to link the header files. Suppose assume that hash include stdio.h and coino.io.h, math.h, many header files are there. Okay, if needed, we are going to include these header files. These header files can take place at the time of linker. If suppose we are going to use the macros, hash define pi 3.14. This we call it as macros. These macros also takes place at the time of the linker. Finally, we are going to generate the executable file. And this loader. Loader is a part of our OS. It performs the task loading the executable files into the memory. Finally, we are going to generate the final machine level language code. Let us take the simple C compiler. Okay, the C compiler translates the program into the low level language into the assembly level language code. After that, assemblers can translate that into a machine understandable language code. After that, the linkers, any header files we are going to include or any macros we are going to use in our program that can be takes place. And after that, this loader can load that memory into the memory, and a compiler converts a high level language to the low level language code. Assemblers can take place low level language code into the machine level language code. And let us discuss what is the difference between the interpreter as well as the compiler. In interpreter, translates the program one statement at a time. Means statement by statement you are going to convert. In case of compilers, scans the total program at a time and converted into the at only once. And interpreter can takes the less amount of time to analyze and the source code, but the overall execution time is slower. But in case of the compiler, large amount of time to analyze, but overall execution time is very faster. And in case of interpreter, no intermediate object code can be generated. But here, in case of compiler, we are going to generate the intermediate object code file. In interpreter, we are going to execute the line by line translation process can be done. Whenever the error can raises in between, let us stop the execution process and generate the error. But in case of the compiler, whole program can be converted at a time and generates the errors. The examples of the interpreter is Python, Ruby, and in case of the compilers, the examples are C and C++. Finally, we are going to discuss the structure of a compiler. Mainly your compiler can be divided into the two parts. First one is an analysis part as well as a synthesis part. In analysis part, that is call it as a machine independent, that is also call it as a language dependent. But in case of synthesis, this is a machine dependent one and language independent. In compilation process is partition into the number of sub-processes is called it as a phases. And let us discuss what is meant by the analysis phase as well as the synthesis phases. The front end of the compiler is also called it as the analysis phase. In the analysis phase, combinedly three phases are interlinked. First one is a lexical analysis phase, syntax analysis phase as well as a semantic analysis phase. Combinedly these three phases is also called it as the analysis phase. After analysis phase, we are going to generate the intermediate code. This intermediate code acts as an intermediate between the analysis phase as well as the synthesis phases. Finally, the intermediate code can be goes to the synthesis phase. After that, code optimization can be done. Finally, we are going to generate the code generation. Means using the code generation phase, we are going to generate the assembly level language code. These two phases combinedly is called it as the synthesis phases. And also, this analysis phase as well as the synthesis phases connected between the symbol table as well as the error handler phase also. Now let us discuss what is meant by the pass as well as the phase. A compiler can have the many phases as well as the passes. A pass is referred to the traversal of a compiler through entire program phase. While compilation process, many phases are interlinked. Means many phases are divided. Okay, starting from the lexical analysis and ended with code generator phase. And each and every phases are connected with each and every other. The first phase, lexical analysis phase, can generate the output. That output goes to the input of the next phase. Like that, each and every phases are interlinked. A pass can have more than one phases. Now, let us discuss with some objective questions. These objective questions are very useful for any competitive exams. Compiler translates the source program to, first one is executable code, machine code, binary code, both B and C. And whenever the compilation translation, we are going to use machine generates either machine code as well as the binary code. Binary code means there is in zeros and ones. Finally, the answer is D. The second question, how many main parts of compiler are there? 1, 2, 4 and 8. Only 2. Why? Because there is a synthesis phase as well as the analysis phase. And let us see the references of the material as well as the sources. First one is Greeks for Greeks and second one is an NPTEL notes. These two are the links we are going to use. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.